Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with atomic structure for NEET 2024. Now students, you have already gone through the chapter, you know almost everything about it. So this is time to revise some of the important points and go through some numericals, that is the questions which were asked previously, so that you are exam ready. Keeping that in view, today we will go through some important points which will help you to score very good marks in the exam. Before I go to the questions, we will see some important points. Today I have not covered all the points of the chapter. In my next video we will continue with the same topic. Again I will give you some points. When I have discussed the numericals, I have also told about the formula which has to be used particularly for that type of question. So by practicing more and more questions, it will help you to attempt the questions very easily. So wishing you all the best. We start our video today. Now when we go through the important points, the first main thing which you should know is that all the atoms except hydrogen are made up of electrons, protons and neutrons. Now why I wrote except hydrogen? Because in normal hydrogen there is no neutron. Electron is there, proton is also there, but neutron is not there. Okay. Hydrogen atom has one electron and one proton. That is normal hydrogen atom. I am not talking about the isotopes. Next we have to see the subatomic particles. Electron. The nature and existence of electron was established by some experiments, and the experiments were on conduction of electricity through the gases, that is discovery of cathode rays. And J.J. Thomson determined E by M value and proved that whatever gas is taken in the discharge tube and whatever be the material of the electrodes, the value of E by M will always be a constant, means same value. So we can conclude that electrons are the common universal constituents of all the atoms. Okay. So it was found that E by M value, it was same every time. Now electron, it carries 1 unit negative charge. It has 1 unit negative charge, and if we state the charge in coulomb, it is minus 1.6 into 10 to the power minus 19 coulomb. The mass is 9.1 into 10 to the power minus 28 grams. On converting to kgs, naturally it will be 9.1 into 10 to the power minus 31. Now in my video I have given the notes also, so you can use these points as your notes for quick revision. So this video will serve both the purposes. You can revise, at the same time you can also practice numericals with me. So please subscribe to my channel and continue watching till the end. There are numericals. I will try to cover questions in every video. So please subscribe to my channel. It will help you all. And it will also help me. So next subatomic particle which we have to see is proton. Proton, it carries unit positive charge. So it is a positively charged subatomic particle. The nature and existence of proton was again established by the discovery of positive rays. It was done by Goldstein. And it carries plus 1.6 into 10 to the power minus 19 coulomb, or we can say 1 unit positive charge. Okay. And its mass is 1.672 into 10 to the power minus 24 grams. So its mass is definitely more than that of electron. It was named as proton by Rutherford. So these are the important points for the proton. Next subatomic particle which is very important is neutron. It is a subatomic particle, carries no charge, so it is neutral. From neutron, you can remember neutral. And I know everybody knows this. It is slightly heavier than proton, little bit heavier. Its mass is 1.675. You see, one decimal is here. 1.675 into 10 to the power minus 24 grams. It was discovered by Chadwick. And for neutron, it was discovered by when beryllium was bombarded with alpha particles. By bombarding beryllium with alpha particles is helium. Helium nucleus is alpha particles. So when beryllium was bombarded with alpha particles, they got carbon 12 and neutron was produced. For the neutron, E by m value is 0. It's important, may come. For a neutron, E by m value is equal to 0. E by m value of neutron is 0. E by m equal to 0. Now, according to Rutherford's model of atom, we know that there is a nucleus at the center of the atom. It is of very small size. It occupies very small size and it has very high density. The electrons revolve around the nucleus in energy levels. We call them energy levels or shells. Slowly we will also see the concept of orbitals that we will see afterwards. Next, very basic thing, atomic number equal to number of protons in the nucleus. How many protons are in the nucleus? That gives atomic number of that element. And mass number is equal to number of protons plus number of neutrons of that element. Next, there are some important terms like isotopes. Isotope are the atoms of the same element, means in the same element there are atoms which have same atomic number. Now see, the element is same, so the atomic number has to be same, but they have different mass number. As we can see, for hydrogen there are 3 isotopes. The atomic number for every one is 1 only. For each it has to be 1, otherwise when we change the atomic number the element will change. But the mass number can be 1 or 2 or 3. Similarly, there are other species called isobars. Isobars are atoms of different elements. Here the elements are different because they have different atomic number. So once, as I told you, you also know atomic number changes, element will change. So they have same mass number here. Mass number is same but atomic number is different. You see, for argon, potassium and calcium, all are having mass number as 40. But you see, for argon 18 is atomic number, for potassium 19 and for calcium it is 20. Calcium is 20. So these are all examples of isobars. Next, in important topic of this chapter, important point we can say, electromagnetic radiations. Now what are they? Electromagnetic radiations are energy waves which contain both electric and magnetic vectors perpendicular to each other. Okay, they are having electric and magnetic vectors which are perpendicular to each other. They do not need any medium for propagation. They travel with the velocity of light. Material medium is not needed for propagation. Now based on this, we can determine the frequency of electromagnetic radiation using the formula nu equal to c by lambda, where nu is the frequency, c is velocity of light, lambda is the wavelength, and wave number is represented by nu bar, that is 1 by lambda. Next, energy. If we see energy, now Planck's quantum theory stated that the energy is emitted or absorbed in the form of energy packets. in the form of energy packets. What do we call them? Quanta. Quantum of visible light is called as photon. Only few wavelengths are visible to us. For that visible light, for that quantum of visible light, we call as photon. For one quantum, energy is given by h nu. This is energy of one quantum, h nu, where h is Planck's constant. Its value is 6.626 into 10 to the power minus 34 joule second. And nu is c by lambda. So h nu we can also write as h c by lambda. Next we have to see what is hydrogen spectrum. Now hydrogen spectrum is a line spectrum, and the lines will lie in visible or ultraviolet or infrared regions, and these lines can be classified into 5 series. I will deal with this in little detail in the next video which I post. So today these are some of the important points which I discussed. I am limiting my important points till here so that I can discuss some numericals also with you. So some numericals of this chapter. When I discuss the numericals, since we are revising, I will also give you the formula so that you can easily revise. Stating the first one. If radius of second Bohr orbit of He plus ion is 105.8 pm, what is the radius of third Bohr orbit for Li2 plus ion? Okay, so there is a relation. R is directly proportional to n square by z. So for the third orbit of Li2 plus, z will be 3, n is 3. For helium, for the second orbit, value for n will be 2 and z also is 2. So using this one, for lithium we will get R3 because it is the third Bohr orbit, we are writing as R3. R3 for Li2 plus divided by, we will take this proportionality for both the ions and then we divide that of lithium by helium. So R3 Li2 plus divided by R2 He plus will be equal to n1 square by n2 square into z2 by z1, because z is in the new denominator, so it will get reversed. So z2 we get here. Putting all the values, we get R3 for lithium divided by 105.8. It is given in the question. Will be equal to n1 square. What is n1 square by n2 square? This is n2. n2 is 2. n1 is 3. So n1 square by n2 square is 3 by 2 into 3 by 2 into z2 by z1. What is z2? z2 is 2. z1 is 3. Putting all the values and multiplying, and when we solve this equation, this 2 gets cancelled, 3 gets cancelled, and 105.8 we have to shift it to the right side. It will go to the numerator. So it will be 105.8 into 3 by 2. So finally we get 158.7 as the answer. So you can write and practice the sum. Next one, this is very basic. This is for lutetium. This question came already, it has come in the exam once. Lutetium, they have given the atomic number and mass number. Atomic number is 71, mass number is 175. We have to find number of protons, neutrons and electrons. Now mass number includes, that is 175, includes number of neutrons and protons both. So n plus p is 175. And atomic number, whatever is given, that will be, atomic number is number of protons. So since atomic number is number of protons, so number of protons will be 71. And in a neutral atom, proton and electrons are same in number, so electrons also 71. Number of neutrons will be mass number minus number of protons. So what is mass number here? 175 minus number of protons is 71. So when we do 175 minus 71, we get 104. That is the number of neutrons. It is a very basic question, but we should be careful while we are doing it. Next one is a very good question. Calculate number of neutrons in 18 ml of water. Now 18 ml means 18 grams. That you all know. Now we need to find out number of moles first. How we calculate moles? Given mass divided by molecular mass. Now in this question, given mass is also 18 grams, and as we know for water, molecular mass is also 18 grams. So number of moles will be 18 by 18, that is equal to 1 mole. And 1 mole of water will have 6.023 into 10 to the power 23 molecules of water. Now for 1 molecule of water, there are 8 neutrons, because water H2O, hydrogen has no neutron, oxygen has 8 neutrons. So in 1 molecule of water, there will be 8 neutrons. So total number of neutrons will be how much? This is the number of particles, 6.023 into 10 to the power 23 multiplied by number of neutron in 1 molecule. Total number of molecules is 6.023 into 10 to the power 23. We have to multiply by 8. Why we are multiplying with 8? Because in 1 molecule of water there are 8 neutrons. On multiplying, we get this value 48.184 into 10 to the power 23 neutrons. So I hope you all understood how you got this number, magic number 8. In H2O, water, hydrogen has no neutrons, normal hydrogen. Oxygen is having 8 neutrons. So total in the molecule there will be 8 neutrons. So we are multiplying this number 6.023 into 10 to the power 23 by 8. Now this number we got from here because we calculated moles, number of moles. Since it is 1 mole, it is 6.023 into 10 to the power 23, which we are multiplying with 8. 8 is number of neutrons in 1 molecule of water. So finally we got 48.184 into 10 to the power 23 neutrons. So usually we find that this type of questions come in the exam. In my subsequent videos, I'll try to upload more questions which will help you in your preparation. All the best for your exam once again. Please subscribe to my channel. Thanks for watching my video. Thank you all very much.